Hello students and welcome to in this our YouTube channel. Students, we are in the topic of electrochemistry, and in our today's lecture we are going to discuss the nickel cadmium or Nicad storage cell. Students, nickel cadmium cell is a secondary dry cell. In other words, it is a dry cell that can be recharged. And in our last lecture we have seen the secondary types of cells, that is secondary voltaic cells. In that we have seen the examples lead storage cell as well as the different batteries. So along with that we are using one of the example of it, that is nickel cadmium or Nicad storage cell that can be recharged. This cell can be recharged again and again. Now here anode of this Nicad storage cell cadmium metal we are using, and the cathode is nickel oxide, that is NiO2. This is the important two things that you have to keep in mind while constructing the Nicad storage cell. The electrolyte solution is basic. The electrode reactions now we are going to discuss here: anodic oxidation as well as cathodic reduction, that you have to keep in mind. According to that, first of all we will see the cadmium of which the oxidation will take place. The OH minus ions will combine with this cadmium solid, then it will form CdOH twice, that is cadmium hydroxide, with the loss of 2 electrons. And at the cathode NiO2 is present, and to this the moisture H2O, when it comes in contact with it, and as by receiving 2 electrons from the anode, it will form NiOH twice, that is nickel hydroxide, along with 2 OH minus ions. So this is the reduction process. And if you want to write the overall cell reactions for this, or the combining reactions for this cell net cell reaction, then you will get by the loss of 2 electrons from the right hand side of the first reaction as well as from the left hand side of the second reaction, you will get the overall cell reaction like this. The reaction product at each electrode is solid that adheres to electrode surface. Students, here this is the very important conclusion of this cell is the reaction product at each electrode is solid that adheres to electrode surface. What does it means? It means after discharge this will happen, and after recharge this layer will be automatically reduced. The potential of the cell is about 1.4 volt, means the output of this cell, or it produces 1.4 volt electricity. Students, the cell has a longer life than other dry cells. It can be used in electronic watches, calculators, photographic equipments, and etc. Means where the 1.4 volt requirement is there, at that in that instruments this cell, that is Nicad cell, can be used. Students, this can be used in wristwatches in our daily life. Now students, we are moving to the next point, that is Mercury battery. This is a new part for your syllabus. Mercury battery is a secondary dry cell and can be recharged. The mercury battery consists of zinc anode amalgamated with mercury. The cathode is the paste of mercury and carbon. The electrolyte is strongly alkaline and made of paste of KOH and zinc oxide. So this is the important part in this. The construction, which is anode and which is cathode, is very important, and these points that you have to keep in mind. Students, you should highlight or underline these sentences. The mercury battery which consists of zinc anode amalgamated with mercury, and cathode is a paste of mercury and carbon, and the electrolyte is nothing but alkaline, strongly alkaline, and made up of KOH and zinc oxide. Now we are going to look at the cell reactions which are taking place at respective electrodes. In that, the first case is anodic oxidation. Anode, according to our statement, we have said that zinc, which is we are using as a anode, and it will converts into zinc oxide with the OH minus ions, that is hydroxide ions. So it will form zinc oxide and with the loss of 2 electrons. This is nothing but the anodic oxidation, and at the same time cathodic reduction will take place. Mercury oxide, that is HgO, will combines, or we can say that with the gain of 2 electrons from the anode, it will converts into Hg, that is mercury, and with the help of water molecules, that is moisture also. So students, the overall cell reaction with the loss of 2 electrons from the both sides, you will get Zn plus HgO, it will convert to ZnO plus Hg. So this is the overall cell reaction of this cell. The overall reaction involves only solid substances. There is no change in electrolyte composition during operation. Means electrolyte will remains as it is. Students, the mercury battery therefore provides more constant voltage, that is 1.35 volt is the output voltage of this cell than the lac-lanches, or we can say the dry cell. It also has considerably higher capacity and longer life than that of the dry cell. Now students, the mercury dry cell finds use in hearing aids, electric watches, pacemakers, etc. This is a very important use of this cell. Now students, this is the reduced part of your syllabus, and after that H2O2 fuel cell is also there for your syllabus part. Now we will see some drawbacks of fuel cells. Before going to that, this diagram as well as construction is present in your this syllabus. So anode and cathode are porous carbon rods for the H2O2 fuel cells, and these carbon rods containing a small amount of finely divided platinum metal that acts as a catalyst. Students, the electrolyte is a hot aqueous solution of KOH. You will notice here the electrolyte which we are using is nothing but the hot aqueous solution of KOH. Carbon rods immersed into electrolyte are shown in the figure. At both the sides you will notice here negative terminal, that is anode, as well as positive terminal as a cathode, and these two anode and cathodes, they get dipped into the electrolyte which is nothing but the hot aqueous solution of KOH. So this is the simple construction of this H2O2 fuel cells. Now drawbacks are included in your syllabus. H2 is a hazardous to handle and the cost of preparing H2 is very high. This is the first drawback of this fuel cell. The second thing is that below the hydrogen electrode the negative standard potential increases, and above hydrogen electrode the positive standard potential is increases. So this is the second drawback of it. E0 values apply to the reduction half reaction that occur in the forward direction as written. That we will see in the next chart of which is included in your syllabus, that is reduction potentials. Students, this is the fourth important point that you have to understand before going to the electrode potentials. Higher the E0 value of half reaction indicates greater tendency to occur in the forward direction. and in turn greater tendency for the substance to reduce. Means as the E0 value of half reaction is greater, it indicates the tendency to occur in the forward direction is more. Means that substance is the greater, has a greater tendency for the reduction process. Now conversely, or we can say the vice versa, low, that is E0 value of half reaction, which indicates there is a greater tendency to occur in the reverse direction or for the substance to oxidize. Means it will oxidize quickly or very easily. The half reactions are listed in the order of their decreasing tendency in the forward direction. Now students, electrochemical series, this is a very important part. For the better understanding, you just go on following their key points of electrochemical series, you will get the important information. Now students, applications of electrochemical series. In this point we will see the relative strength of oxidizing agents, and that we will see with the help of this chart, which is provided on page number 116 from your textbook. And before going to it, you should understand the terms which are present in it. The species on the left side of half reactions are oxidizing agent. E0 values is a measure of tendency of the species to accept electron and get reduced. This is nothing but the value which decides whether that substance will accept electrons or lose electrons. This is nothing but the strength of the substances as oxidizing agents. Larger the E0 value, greater is the oxidizing strength. Means E0 value will decide oxidizing strength of that species. The species in the top left side of half reactions are strong oxidizing agents. As we move down the table, E0 values and strength of the oxidizing agents decreases from top to bottom. So students, this is nothing but the general instructions how to describe, or we can say how to know the relative strengths of oxidizing agents. Now vice versa, we can also describe relative strength of the reducing agents. You just go through it, you will get all the important instructions. Now if you look at the spontaneity of the redox reaction, in this point you can say that whether a corresponding particular redox reaction is a spontaneous or non-spontaneous, or which type of reaction is present. A redox reaction in galvanic cell is a spontaneous only if the species with higher, or you can say the E0 value is reduced, that is accepts electrons, and that with lower E0 value is oxidized. Means this will happens with the donation of electrons. The standard cell potential must be positive for a cell reaction to be spontaneous. This is the very important sentence, students, that you have to highlight it or keep in your mind for better understanding. The cell potential must be positive for a cell reaction to be spontaneous. Now students, under the standard conditions, this will happens. The applications of electromotive series is predicting spontaneity of redox reactions. Means some questions may be asked in your theory exam, whether the given reaction or the cell or the species in the specific reaction is spontaneous or not. So this is very important point. Application of electromotive series is a predicting spontaneity of redox reactions from the knowing the values of standard potentials. And the pattern of that question is here only in your textbook they have mentioned. At standard conditions, would Ag plus ions oxidize metallic magnesium? That question is asked to you. To answer this question, first we write oxidation of magnesium by Ag plus. So students, left hand side electrode, that is oxidation, at the anodic oxidation will take place, and that process we have written here. And at the right hand side reduction will take place, and that reaction also we have written here. And with the loss of 2 electrons from both the sides, you will get the overall reaction, and that overall reaction we have written here. And from the table 5.1 of electrochemical series, you will get the E0 cell that we have determined it would be 3.17. EMF being positive, the cell reaction is spontaneous. Thus Ag plus ions oxidize to metallic Mg, and this will gives us the important of this reaction, that is, this reaction is a spontaneous reaction. So students, this is a case how we can say whether the particular reaction is spontaneous or not. And this is nothing but the problem which is asked in your theory examinations. For better understanding, you can just follow other examples too. Students, the important general rules are also given in your textbook, whether you can follow means you can follow these rules for the problems. An oxidizing agent can oxidize any reducing agent that appears below it. From observing the table which is given or provided in your textbook, you can judge, means with an oxidizing agent can oxidize any reducing agent that appears below it and cannot oxidize the reducing agent appearing above it in the electrochemical series. And reducing agent can reduce the oxidizing agent located below it in the electrochemical series. So students, this is the electrochemical series. You can put this electrochemical series in front of you, and by reading all the important instructions related to it, you can judge or you can solve many different problems which are based on this electrochemical series. So this is all about in our today's lecture. Thank you very much.